Hi friends, welcome back to our YouTube channel. Today we have to discuss about Java program for addition of two matrices. To perform the addition operation between the two matrices, we require totally three matrices. So that are A, B and X, where A and B are two input matrices and X matrix is used for storing the result of addition of matrices A and B. Now matrix A has the size 3 by 3. So where 3 contains 3 rows and here this 3 contains 3 columns. Okay, matrix A contains 3 rows and 3 columns. First row contains the elements 1, 2, 3. Second row contains the elements 4, 5, 6. The third row contains the elements 7, 8, 9. Now, matrix B has the size 3 by 3. It contains the elements. First row contains 1, 2, 3 elements. Second row contains 4, 5, 6 elements. The third row contains the elements 7, 8, 9. Now we have to perform the addition operation between the corresponding elements. Okay, to perform the addition operation, first the condition is number of rows and number of columns are equal in two matrices A and B. Here matrix A contains 3 rows and matrix B also contains 3 rows. Both are equal. Matrix A contains column size 3 and matrix B contains the column size 3. Hence, we have to perform the addition operation between the two matrices, between the corresponding elements of two matrices of A and B. So here first this element is added with this element because they are correspondence element. 1 plus 1, that is a 2. Next, here 2 are the corresponding elements. We are adding them, 2 plus 2. Next, here 3 are the corresponding elements. We are performing the addition operation. Next, here 4 and here 4. Between these two elements, we are perform the addition operation. Next, matrix A, we are taking 5. In matrix B also we are taking 5. Between them we have to perform the addition operation. In the same way, 6 plus 6, 7 plus 7, 8 plus 8, 9 plus 9. Okay, so between the corresponding elements of two matrices A and B, we have to perform the addition operation. Now, whatever the result we are getting, that result is stored in resultant matrix X. So this is the resultant matrix X. The first row contains 2, 4, 6. The second row contains 8, 10, 12. The third row contains 14, 16, 18. How we are getting this result? In Java programming. Okay, now we can go to the Java program. Before going to the Java program, matrix A size can be read from the keyboard at runtime and matrix B size also read from the keyboard at runtime. Matrix A elements are also read from the keyboard at runtime. Matrix B elements are also can be read from the keyboard at runtime. Okay, so to read the values from the keyboard at runtime, we have to use scanner class. Scanner class is available in util package. First, we have to import the util package. After that, we have to import the scanner class from the util package. Okay. Now, first, we have to write import statement. Import java.util.scanner. Next, we have to create one class. The class name is matrix addition. Okay. Next, we have to write the main method. public static void main string arguments. Next, we have to create the object for the scanner class. Scanner sc is equal to new scanner system.in. Here, scanner is a class that is available in util package. SC is the object reference. New operator is used for allocating the memory for the object SC. And scanner of system.in is the parameterized constructor. System.in is used for reading the input from the keyboard. It creates the environment. Next one. System dot out dot println, enter the size of matrix A. Enter the size of matrix A. So here the size of the matrix can be read from the keyboard. Okay. Int r is equal to sc dot next int next int c is equal to sc dot next int. So here matrix A contains rows and columns. So size of the matrix is nothing but we have to read the row size and column size. Row size can be denoted by letter R and column size can be denoted by letter C. Okay, whatever the row size value and column size values are read from the keyboard, Java compiler can take that values as a string values. To convert the string values into integer values, we have to use next int method. So this method convert the string values into integer values. To call this method in the scanner class, we have to use the object. So sc dot next int. After converting, that value can be assigned to the variable R. So R represents the row size in matrix A. In the same way, column size is represented by variable C. Okay. So row size is nothing but variable R, column size is nothing but variable C. In the same way, we have to enter the size of matrix B. System dot out dot println, enter the size of matrix B. Here int m is equal to sc dot next int. Next int n is equal to sc dot next int. So m is nothing but row size in matrix B, n is nothing but column size in matrix B. Whatever the values that we are entered from the keyboard, that values can be taken by the Java compiler as string values. To convert the string values into integer values, we have to use the method next int method. This method is available in scanner class. To convert to access that method, we have to use one object. That object is sc dot next int method. After converting, that value can be assigned to the variable m and n. Okay. Next, we have to construct the matrix A, matrix B, and matrix X. Okay. So int A matrix is equal to new int matrix A, so row size is R, matrix A column size is C. Okay, this is the construction of matrix A. In the same way, int B open square bracket close square bracket open square bracket close square bracket is equal to new int B of row size is m and column size is n. Next, int x open square bracket close square bracket is equal to new int x row size is r and column size is c. No problem. So here, what is the meaning of this line? So matrix A can be declared by using this syntax. Okay, matrix A row size is R and matrix A column size is C. Okay, whatever the row size and whatever the column size that we are entered from the keyboard, that values are stored in this place. What is the size of this matrix, how many number of elements that we are entered from the keyboard. For example, row value is 3 and column value is also 3 into 3, that are 9 elements are entered from the keyboard. That elements are stored in matrix A. So how much amount of memory is allocated for all the elements of matrix A? So every integer occupies 4 bytes. So 9 elements are there in the matrix A. 9 into 4, that is 36 bytes of memory is allocated to matrix A. In the same way, row size of matrix B is m, that is equal to 3. Column size of matrix B is n, that is 3. So 3 into 3, 9 elements are present in matrix B. So 36 bytes of memory is allocated because each integer occupies 4 bytes. 9 elements, 9 into 4, that is 36 bytes of memory is allocated to matrix B. Okay. In the same way, matrix C also 36 bytes of memory is allocated. So matrix X size is nothing but we are taking R and C. R is nothing but row size and C is nothing but column size. So total 9 elements are present in the resultant matrix, that is X. Therefore 36 bytes of memory is allocated. Okay. Now to perform the addition operation between the two matrices, what is the condition is that if row size of matrix A is equal to row size of matrix B, that is R is equal to M, and that is logical, and column size of matrix A. Column size of matrix A is nothing but C equal to column size of matrix B is n. If both conditions are true, then we have to perform the addition operation between the two matrices. So system dot out dot println matrix addition is possible. Once matrix addition is possible, okay, now we have to enter the elements into the matrix A from the keyboard. So system dot out dot println, enter the elements into matrix A. Enter the elements into matrix A. For that purpose, we have to use two for loops. Okay. For I is equal to 0, I less than row size, I plus plus. Next one, for j equal to 0, semicolon, j less than c, semicolon, j plus plus. The first for loop is used for rows, the second for loop is used for columns. In the first for loop, the row size is r, in the second for loop, column size is c. Now we have to enter the elements from the keyboard. A of ij is equal to sc dot next int. So we have to read the elements from the keyboard. Whatever the elements that we are enter from the keyboard, the Java compiler can take as string values. That string values are converted into integers by using the next int method. This method is available in the scanner class. To access that method, we have to use the object. Therefore, sc dot next int method. After converting, that value can be assigned to the particular index. Okay. Next, whatever the values that we are enter from the keyboard, that values are stored in the matrix A at the corresponding index I and J. Next, so whatever the elements that we are entered from the keyboard, that elements are printed. System dot out dot println, the entered elements in the matrix A are the entered elements in matrix A are. Now again we have to take the for loop. For I equal to 0, semicolon, I less than r, semicolon, I plus plus. Next one, for j equal to 0, semicolon, j less than, so he c, semicolon, j plus plus. Now system dot out dot println, I am take only print instead of println. A of I of j plus one space. So this space is used for after printing the element in matrix A. So we have to use one space. This space is used for separating the any two elements of matrix A. Okay. So after that we have to use system dot out dot println. So this line is used for after printing all the elements in the first row, the control goes to the second line by using this statement. So this statement is used for printing all the elements of matrix A in matrix form, not in a single row, not in a single column. To print all the elements in matrix A in matrix form, we have to use between the closing of two for loops, we have to use system dot out dot println line. Okay. So in this way, we have to read all the elements of matrix A. Whatever the elements that we are enter from the keyboard, that elements are printed. The same task can be used for matrix B, so that I am taking copy and paste. So copy and paste here because of time reducing. Now enter the elements of matrix B. Matrix B are, so in the matrix B, row size is M and column size is N, and to print the elements in matrix B, between the two elements we have to use one space. For that purpose we have to this one. After printing all the elements or all the elements in a particular row, the control automatically goes to the next line by using this statement. Okay. Next, in the same way, here also we are changing. Enter the elements in matrix B. So here the row size in matrix B is M. The column size in matrix B is N. Next one, B of Ij. B of Ij is equal to SC dot next int. So here these lines are used for reading the elements into matrix B. Whatever the elements that we are read, that elements are printed in this way. Okay. So next we can go for the logic, matrix addition logic. Okay. For I equal to 0, I less than R semicolon I plus plus. Next, for J equal to 0 semicolon J less than C semicolon J plus plus. Next, so the addition is C, not C, here X. X of I of J is equal to A of I of J plus B of I of J. So between the corresponding elements of matrix A and matrix B, addition operation can be done. Whatever the result we are getting, that result is stored in matrix X, because matrix X is the resultant matrix. Okay. So this is the simple logic for performing the addition operation between two matrices A and B. The result is stored in matrix X. Now we have to print matrix X. So system dot out dot println the resultant matrix X is the resultant matrix X is, again we have to use two for loops. The first for loop is used for rows. I equal to 0 semicolon I less than R semicolon I plus plus. The second for loop is used for columns. For J equal to 0 semicolon J less than C semicolon J plus plus. Next, so system dot out dot println C X of Ij plus one space This space is used for separating the elements of matrix X. Next, between the closing of two matrices, we have to write system dot out dot println. So this line is used for after printing all the elements of a particular row, the control automatically goes to the next line by using this statement. Okay. After that, we have to close for loop. Okay. Next one is if close. Up to now if close, then we can go for else. System dot out dot println matrix addition is not possible. Matrix addition is not possible. Else close and class close and main method is also close. So here we have to declare the loop variables here int I comma j. Int I comma j semicolon. Okay. Now we have to save this program. So, okay. So save as matrix addition dot java. If it is already there, it can ask do you want to replace it. Otherwise, the program is saved with matrix addition dot java. Now we have to compile the same program. The program is successfully compiled. Now we have to run the same program. Enter the matrix A size 3 by 3. Enter the matrix B size also 3 by 3. We have to enter 9 elements 1, 2, 3, 4, 5, 6, 7, 8, 9. Because matrix A size is 3 by 3, matrix B size is 3 by 3. So in matrix A row size is equal to in matrix B row size. In matrix A column size is equal to column size of matrix B. Therefore matrix addition is possible. Enter the elements into matrix A. 9 elements that we are enter into matrix A. Because matrix A size is 3 by 3. These elements are printed in matrix form. First row contains 1, 2, 3 elements. Second row contains 4, 5, 6 elements. The third row contains 7, 8, 9 elements. Next one, enter the elements into matrix B. How many number of elements that we are enter into matrix B? Matrix B size is 3 by 3. Therefore, 9 elements we are enter into the matrix B. 1, 2, 3, 4, 5, 6, 7, 8, 9. These elements are printed in matrix form and we are getting the result of addition of two matrices between the corresponding elements. Okay, so the result is 1 plus 1 that is 2, 2 plus 2 that is 4, 3 plus 3 that is 6, 4 plus 4 that is 8, 5 plus 5 that is 10, 6 plus 6 that is 12, 7 plus 7 that is 14, 8 plus 8 that is 16, 9 plus 9 that is 19. Between the corresponding elements of two matrices, so the addition operation can be done. The resultant matrix X is printed. So in this way, we have to perform the addition operation between the two matrices and the result is stored in another matrix. Now we can go to the program. So this is the simple program. So thank you for watching this video. If you like this video, please click on the like button and click on the bell icon to get the future updates in my YouTube channel after subscribing my YouTube channel. If you have any doubts, please put your doubts in the comment section. I will clarify your doubts. So thank you one and all for watching this video. Please forward this video to your friends and classmates. Thank you one and all for watching this video.